so today we've got a couple of packages from Licitti. And if you guys remember, Licitti is the company that brought us this awesome battery box with the 1,000-watt inverter built in. And they also have the Gen 2 version of this, which is 2,000 watts. And they have also sent me a new Gen 2, which is supposed to be updated. I think they fixed some issues with the MPPT charge controller, because last time we weren't able to get 20 amps out of it. So I think maybe they've upgraded that. So we're gonna check that out. But the thing that I'm most interested in is in this box right here. And so in this box is a 280 amp hour DIY battery kit that's supposed to fit in their Gen 2 box. And I'm not sure, maybe this will fit in the Gen 1 as well. So let's open this up. Okay, so this is the DIY battery kit. We've got some terminal nuts. They gave us some fiber reinforced tape. We've got bus bars, and it looks like they're numbered. We've got a BMS that is also numbered, and everything seems to be numbered. So there's some kind of plate here. I think this may be a plate that will go on the end of the battery cells. We got a piece of foam that is cut out, has cutouts here, and this I believe is going to be placed on top of the battery cells, and those cutouts will allow the vents to be exposed. We have our assembly manual. So this is already looking like a very good battery kit. Looks very simple, and they're just telling you the steps here to put it all together. Looks real simple. Looks like you're taping the cells together. Looks like this end plate with the BMS will be taped on as well. And then in these ending steps here, it looks like you put on this pre-cut fiberboard. And there's the illustration there of how it's all put together. It seems incredibly simple and straightforward. I'm assuming in here are cells. I'm curious what we will get as far as cells go. And let's take a look here. They look like brand new cells. Let's pull them out and examine them. Certified energy storage grade lithium iron phosphate, 280 amp hour. We've got a model number, which is LFP71173207, 280 amp hour. Its manufacturer is Lithium New Energy Technology. It says the cycle life is 10,000 cycles. I don't see any kind of bloating. So I'm assuming that these are fresh new cells. Okay, and there's all the cells right here. Let's turn them all on their sides and see if we've got any kind of bloating or anything. Yes, there's no bloating. And then, so yeah, also they sent us another one of their Gen 2 box. This is supposed to be an updated version. It basically looks the same from the front. Don't really see any difference. So supposedly the main difference is, you know, they've updated the MPPT charge controller to actually do the full 20 amps. Okay guys, so this is the really great thing about doing these kinds of videos. Yes, whenever we do get a product, then it has some shortcomings and we do the review. Sometimes, hopefully, the manufacturer will see the review and see the things that we pointed out as shortcomings and fix those problems. And in this case, these guys were paying attention because they made these wires much larger. These are 2 gauge, 200 degrees Celsius silicone jacketed wire. So these are larger wires than what the other one had, the first Gen 2 that they sent me. And I can also see that this is a different charge controller. This looks larger. I'm trying to take a picture with my phone. Okay, so it says, it's upside down, but it says the PV input is 55 volts max, and it'll do a 12 or 24 volt battery. Of course, you have to do a 12 volt battery in this because you're limited to the inverter is only going to be able to handle 12 volts. But it says, it does say 20 amp right here. All right, guys, so let's go ahead and build this battery pack. So usually I would start off by top balancing cells before I build a pack, but in this case I'm not going to. We're going to try it without top balancing. And before you guys have a breakdown and get into the comments and start screaming at me, right here it says certified grade A cells generally do not require balancing. And I've built 2 SunFun Kits batteries with their cells, and I did not top balance them, and they were balanced perfectly fine already from the factory. So I think if you got really super high quality cells direct fresh from the factory, they haven't been, you know, mixed up or sent off different places, they're not B grade, I think they come pretty much at about the same state of charge for each cell, because they have testing equipment that they charge these things up. They know how much power goes in to charge it, how much capacity went in, and how much they pull out. So they know exactly how much to leave into these cells so that they'll all be balanced. So we're going to do that. We're going to not top balance. And if we do run into any problems when we charge this battery up, like say, you know, some of the cells are out of balance, I'm just going to plug in this balancer. But I stress to you guys, if you're building a battery, if you're not quite sure where the cells actually originated from, you know, they may be different batches or whatnot, I would recommend that you go ahead and top balance them. That would be putting them all in parallel and then charging them all the way up to 3.65. All right, guys, so I think one thing that I feel like they should have supplied in this kit was some insulation material to put in between the cells. You know, maybe include some extra pieces of fiberboard to go in between each cell, just to give you more insulation between the cells. It's a common building technique and I like to use it. So I don't really have any fiberboard large enough to go between these cells, but I do have these spacers left over from SunFun Kit battery builds, so I'm just going to use those. And also on the back of the BMS bracket, I would like to see something. So I've got a piece of fish paper that I'm going to tape on there. That way we have some more insulation between this bracket and the cells. Alright, so we got the cells taped together with a band of tape at the top and at the bottom. And that's relatively easy to do, and this tape is super strong. So basically you're just going to put the end of it on, pull it across, and then kind of pull the cells tight and then band it all the way around. Now we can put the BMS bracket on, and you can see I got the fish paper taped on to the back. And there we go. That tape really is very strong, and it's holding the cells together very nice. And before you start doing this, make sure you've got the cells oriented the correct way. So your main negative is going to be there, and then positive, then negative, then positive. If you've got them oriented the wrong way and you tape them all together, you're going to have some serious issues and you're going to have to tear it all apart. So now we can put our bus bars on and our BMS wires. I think actually we need to put on this foam on the top because I believe we need the BMS wires to kind of ride above it. We're going to pop these little die cuts out, and we're going to save those because we're actually going to use those later. Okay, there we go. That's stuck down. Now we have a black wire labeled B-, so that's going to be the one that goes all the way over to here. And then one, I believe, is going to go here. And then two will go here. And the wire labeled 3 will go here. And then the main positive wire labeled B+ will end up here. So we're actually going to put our bus bars down first. So we'll put them down like so. Now this part is critical. Make sure your next bus bar goes here and not here. If it goes here, you got sparks and melting stuff happening. Don't do that. So make sure these go in the right spot. There we go. So our main positive will be connected to this little bus bar that sticks out the side over here. And on our negative, it's going to connect to the BMS with this 2-gauge wire. So it's going to go here, like so. I'll put a nut on top to hold it. All right, so we're going to tighten them down. Now you want to be very careful that you do not allow this to slip and touch any other part of these bus bars, because you will have fireworks. And these you don't need to tighten it down to where you break these off or strip them out. That should be good. And before we hook the balance leads up to the BMS, we really should check them with a multimeter to make sure that the wires are connected to the correct cells. So I'm going to start with the most negative and the most positive, and we see 11.1 volts, and then we should go down 8.3, 5.5, and 2.78. Now, that's one thing that I didn't show you guys. The voltages of these cells came lower than I'm used to. They're not too low. They're not 2.5 or below, but they came at 2.78, 2.779, 2.78, 2.78. That's within a safe range. It's definitely lower than what I'm used to. But still it's fine. All right, so we verified that the wires are connected to the correct cells, so we can go ahead and plug in our BMS. There we go. And let's see if we got voltage. I'm going to test the BMS output and the most positive. There we go. We got 11.12 volts. So the BMS is now functioning. We need to put on the little bus bar that connects here, that sticks out. And I think mine came with this little bolt and nut on the wrong side. So keep that in mind if you have that too. I believe that this short side should be here. All right, so we need to find a place to tuck our temperature probe. And you could tape it on top of the cells or just poke it underneath this foam, and that'll be fine. Just as long as it's just kind of setting on top of the cells, it'll be perfectly fine. Now we can pretty much just start putting on this fiber board all the way around the battery. And I think I'm going to start with the bottom. And I'm going to go ahead and assemble these together and then just fold them up around the battery. So you'll want to leave a little gap in between to allow the fold. Just lay your tape down right on top of it. Now let's see if that gap that we left is good enough. Yeah, I think that's perfect. Yeah, that's going to work. So let's do the same thing over here. Just leave a little bit of a gap. Maybe close to a millimeter, but yeah, probably somewhere around a millimeter. I'll do the same thing. There we go. Just Drop the tape right on top of it. That way we don't move anything. All right, now flip this over. Bam, let's set our battery right here in the middle. And I made a big goof. This is the top, and this is the bottom, and this is the side. But I can redeem myself. We'll add this piece, and then we'll offset the battery over here. There we go. Get everything lined up. And look at here. Bam. Side, side, top. Now I'm just going to put a little piece of tape right here just to hold the top for right now, because I don't want to actually fully close it up just yet. So now we can put our negative side on. Put our positive side panel on, and this one's thicker. I guess they figured that there's nothing here to protect the cells, so they might as well make this thicker. Okay, all the corners are taped up, with the exception of the top. I wanted to leave the top open so that I'll have access to the cells up here in case I need to balance them. Basically, in case I need to hook up the active balancer. And with them open up here, I can check with my multimeter as it's charging to see if anything is getting out of balance. So the other thing I want to do is, Roland already built this battery, and I'm stealing this idea from him. But he took these little nubs and put them here. And the reason why is because in the battery box, there's a strap that goes across here. There's nothing to reinforce this corner, so it would get crushed. So if we put these foam nubs here, it won't get crushed. All right, so this battery is ready to be charged up. Now we are charging, and it's going to take a long time because we are charging a very dead battery at about 42 amps. All right, I'll be back when it's charged. All right, so I think we're getting super close to this battery being charged. Let's check how much power is going in. Oh, look at there, we're only putting in 1.8 amps. So it's very, very close. It's just sipping power right now. I do see there's like a little blue light flashing down here on the DMS that I didn't see earlier. You can see it flashing through here. All right, let's see here. Look at there, we got 3.58. Oh, a little high there, 3.72, 3.67, 3.63. Really close. It's letting this one go a little higher than what we probably usually like to see. I'm still okay with 3.7. I've seen some actually allow the cells go up to 3.9, so maybe that flashing is an indication of it balancing or something. Okay, so the charger just now turned off completely. And so let's get a reading on the cell voltages to see where we're at. We got 3.575. We got 3.68. We got 3.63. And we got 3.6, right on the money. These are pretty well balanced just right off the bat. You know, if you really wanted to, if you got a cell that's a little bit high, like this one right here, you could take some resistors, some high wattage resistors, and burn some of that power off. It is going to get hot. So let's see what we got down to by just doing that. Look, we got down to 3.66 just by a few seconds with that resistor on there. So it's just a minuscule amount of power that's different here. All right, so yeah, if you receive cells as good of a quality as I received, I think you basically just build it and skip top balance and charge it up. Now, of course, check it after you charge it. And if it is out of whack, you know, then either strap one of these puppies on or just go through with the resistors or a light bulb or something like that and kind of drain the higher ones down. All right, guys, so with the extra spacers I put in between the cells and probably also charging it, because charging it makes the cells expand a little bit, I've made it to where I can't really get it into the bracket that fits into the battery box. So I think what I'm going to do is I'm going to probably bend this down a little bit to try to get it to go in. So let's see if we can just get it to fit in there for now. So that definitely might be something to consider if you're building this battery. You might want even thinner spacers between each cell. I think also if it was placed in this tray before it was charged up, I bet it would go in. There we go. Okay, that actually wasn't that hard. I just had to kind of bend it out a little bit and it went ahead and slid right in. And I still haven't fully taped the top because after we discharge it, I want to test the thermal sensor to see if it has low temperature protection. I think this is the way the negative should probably be routed. That way when this slides in, it has room for this to go inside and not get snagged on anything. It's definitely a very tight fit, and one thing I'm running into right now is this buckle on this strap right here is up a little too high, and if you could see inside there, it's hitting the charge controller. So you need to adjust this strap to where this buckle is down lower. And unfortunately, I've already got the battery kind of wedged into the tray and I don't want to do that at the moment. So I'm just going to remove this strap for now. There we go. Now it's going in. And before we connect this positive cable, we need to pre-charge. That should be long enough. All right, there we go. The battery's in. I'm going to leave the back off because, like I said, I want to pull it back out and test the low temperature protection. All right, so let's turn this guy on. There we go. So what we need to do is go into the screen and set up the configuration. And so here's the app. I do like their app. It's very straightforward. Let's go into the settings and let's change the battery capacity to 280. All right, and there's some settings in here that you can't seem to get to from the app, so let's go into the setting like this. Full voltage shouldn't be 12, that's too low. We want that to be like 14.4. And I like the LCD to always be on. So I think you set this to 999 or something. There we go. I think we need to reset the state of charge, and I believe you do that with holding one of these buttons down. Okay, that reset the capacity and the state of charge. Okay, so this right arrow right here, if you long press it, it resets everything. All right, so we're at 280 amp hours on the battery. We are at 100% remaining. All right, so let's try a capacity test. I've got heater plugged in because today is a little cooler. So it'd be fine to run the heater. Let's go ahead and start the AC up. There we go. Now we're pulling, looks like 820 watts, 62 amps. And for the capacity test, basically we're going to see if this will go all the way down to zero. You know, if we burn off 280 amp hours, then we know that the batteries reach their full capacity. I'm not sure if this meter is going to show us anything beyond that. You know, it may actually just go to zero and not show us anything else, but at least if it goes to zero, we'll know that it passed. All right, so I'm just going to let that run And according to the screen, it actually says time remaining is 4 hours and 25 minutes. So that's cool that it gives you an idea of how long you can run that. All right, guys, so we're down to 3%. We're still at 12.2 volts. We've got 7 amp hours left to go. Now it is doing a beep because it does have an alarm set when it gets down below 10 amp hours. That's known. We knew that was in there in the configuration. Okay, so we're down to 2%, and we've just got 6 amp hours to go. Okay, guys, we're down to 1% now. We've got 2 amp hours left. We're still at 12 volts. So I'm quite certain these cells are definitely going to meet the capacity. So it says we're at 0% now, but we do still have 1 amp hour to go. There it is, 0 amp hours. So we have pulled 280 amp hours. These cells meet their rated capacity. They're clearly brand new cells and very good quality. So nothing fishy there, guys. So you don't have to worry about these cells at all. Now, I don't think it's going to actually show us any negative amp hours here. There's probably, I'd say maybe 4 amp hours left in there. Possibly more, 4, 5, 6, something like that. But we're not going to be able to accurately know because this meter's not going to really tell us. So I'm just going to go ahead and kill the test right now. All right, so really what I want to do right now is I want to hook up solar. And I've got a 365 watt panel, I think that's what it is. And let's plug it in here. And it looks like we're charging. Oh, we're charging at 240 watts. Very nice. Oh, almost 20 amps, 19.86. So this charge controller does work, guys. Great. So the last charge controller they had in these wouldn't do the 20 amps. And so we're doing 19.75. It's close enough to call it a 20 amp. That's really good. So good on Licitti for resolving that problem. Okay, so now that we know the 20 amp charge controller does actually do 20 amp, I want to pull this battery back out. I want to see if it has low temperature charge protection. So let's try to freeze this guy here. Yeah, there it is. We stopped charging. And now it's back. All right, so great. We do have low temperature charge protection on this BMS. Fantastic. All right, guys, and lastly, I know some of you are wanting to know, will this Licitti battery kit work inside the Gen 1 battery box? Let's find out. I think we're hitting a snag. I think there's these little pieces inside here. I think these are in the way. That's not what it is, actually. Something else is in the way. Oh, okay. It's not actually these side post thingies. It's the width between here and here. This thing is coming in at just slightly over 13 inches. And inside here, I think we've got that right here, but it appears to get more narrow as you get inside. Yeah, it tightens up. So now we're like less than 13 inches. Yeah. So that's the thing, it's this. So it actually, if you had thinner spacers in between, and maybe if you left off this side and this side, it may actually work. You could get it to work, but you're gonna have to do a little bit of trimming or something like that. All right, guys, so my final thoughts on this battery kit. I like it. I actually like it a lot. It's a really good kit. The only thing that I think I could say is would have been nice if they gave you some extra fiberboard to go in between each cell and one behind the BMS. Beyond that, it's a very good kit. They did a great job. And they selected good cells, so that's really good. I was a little bit concerned with what kind of cells they're going to provide, but they did a good job there. On the updated version of the Gen 2, they did a great job by upgrading these wires, and they did a great job with upgrading the charge controller to actually handle 20 amps. So that's fantastic. Great job, guys. Thanks to Licitti for sending us this battery kit and the new Gen 2 for testing. Give me your comments in the comment section, and I'll catch you guys on the next one.